We'll call this example 4. Now, the hardest questions in these examples look like this. Instead of saying, find the third term, find the fifth term, they come up like this. Find the term containing, and they tell you something about the variable and its power. So find the term containing x to the 9 in the expansion of 3x squared minus 2 over x to the power 9. So when we think about our formula, and I'll write our formula out here in green, tk plus 1, n choose k, a to the n minus k, b to the k. When we look at our formula, we know what n is. N is the exponent. So we know that n is 9 all the way through. We know what a is, because that's our first term in our binomial, and we know what b is. But the problem is we don't know which term has x to the 9. And then so what we're going to do is we're going to try and figure out which term has an x to the 9, and we're going to look at a couple of different strategies for doing that. And then once we find out which term it is, then it becomes just like last question, where we know k, we know n, we plug in everything and simplify, and it's not too bad. But the hard part is going to be finding out which term has the x to the 9. So I'm going to start by using our formula and putting in everything that I do know. So I don't know what k is, so I'm going to leave that as k plus 1. I know that n is 9. I don't know k. I know that my a value is 3x squared, 9 minus k, and my b value is negative 2 over x to the k. How many terms in total are there going to be in the expansion? 10. So the first way that you could do this is you could go through, start with term 1, see what it looks like. Start with term 2, see what it looks like. Then go to term 3, see what it looks like. So if I looked at term 1, when I'm looking at term 1, k is 0, always 1 less than the term. And what we're going to do temporarily is we're going to ignore everything that affects the number in front, because we're really only looking for which term has an x to the 9. We don't care what number is in front. We just need it to have an x to the 9. So we're really only concerned about the variable. If I look at my first term, and I'm just considering my x's, k would be 0. How many x's would I have in my first thing? If k is 0, can you see you'd have a power of 9? And if you had x squared to the power of 9, what would you have here? You would have x to the 18. And if k is 0, what does that anything to the 0 make this whole thing? 1. So my first term would have an x to the 18. We're looking for x to the 9, so it's not the first term. If we did our second term, then k would be 1. Can you see in this one you'd have 9 minus 1 is 8. In the first thing with the variables, you'd have x to the 16. And if k is 1, over here you would have negative 2 over 1x on the bottom. If you simplify that, how many x's are going to be in the second term? 15. If we did our third term, then k would be 2. There would be x to the 14 here. If k is 2, you would have 2 x's on the bottom there. If you simplify that, you would get x to the 12th. The purpose of doing the first three is in these expansions, there's always a pattern. Can you see a pattern that's happening with the exponents? They're going down by 3. And sure enough, the next one will be x to the 9 because you're going to put in a 3 there. You're going to get 12 on top, subtract 3 on the bottom, and you'll get x to the 9. And so we're going to know that it's going to be term 4 that we want to find. So this is the pattern method. I'll label it number 1. Pattern method. You find your first, you find your second, you find your third, you find a pattern, and then you keep going on that pattern. It just so happened that the very next one in the pattern is the one that we're looking for, but I could have asked this question saying, find the one containing x to the 3. Then you'd have to keep going, x to the 6, x to the 3, you would know it's term 6. So we have this as the first method is the pattern method. Related to the pattern method is sort of a trial and error method. You pick a value of k. You say to yourself, I'm going to say it's going to be k is 5. And if I start with k is 5, this exponent here will be 9 minus 5 will be 4. That will give me x to the 8 here, and this will be a 5, giving me x to the 5 on the bottom. That simplifies to be an x to the 3. So if you started with 5, you get x to the 3, which is too small. You want an x to the 9. So then you sort of do trial and error. Well, I need more numbers on top, so I need my k value to be smaller. So then maybe you say, I'm going to try k as 3 next. And when you try k as 3, this will be 9 minus 3 is 6. That will give me x to the 12 on top, x to the 3 on the bottom, and that gives me x to the 9. And so it's sort of a guess and check, but you try a number and then figure out if you need to go up or down. And it usually doesn't take you more than 2 or 3 tries before you figure out that k is equal to 3. For the majority of your questions, these are going to be, I think, the best methods. I really like the trial and error because you're just doing some mental math with your exponents, and it doesn't take very long to figure out what needs to work. However, I have seen on some final exams that they like the third method, which is the longest method, which is an algebraic method. The algebraic method looks like this. So here's method number 3. Algebraic. So in the algebraic method, you say, well, I'm trying to find the term with the x to the 9. So I know that this equals something x to the 9. I don't know what k is, so 9 choose k is going to be something. I'm going to have 3x squared to the 9 minus k here, and I'm going to have negative 2 over x to the k here. In fact, the only information that we have is stuff with the x's. So we temporarily ignore all coefficients, all the numbers in front. We temporarily ignore them. So I just say on this side, I'm just going to have x to the 9. On this side, with my first term, I would have, well, x squared to the 9 minus k would be x to the 18 minus 2k, because our exponent laws for a power to a power is we multiply. So if I multiply that exponent of 2 times the 9 minus k, I've got to distribute, I'll get 18 minus 2k. And in the second one, I'm going to have, well, I'm ignoring the numbers on top. I'm still going to write a 1 on top just to make it a fraction, but I'm going to have x to the k on the bottom. Continuing with my exponent laws, what exponent law do you use when you divide? You subtract. So x to the 9 has to equal x to the 18 minus 2k, and then I have to subtract k on the bottom. In other words, x to the 9 is equal to x to the 18 minus 3k. And just like we did in our powers, or sorry, in our exponents and logarithms unit, if you're able to get two powers with the same base equal to each other, does it make sense that if they're equal, those exponents have to be equal? And so 9 has to equal 18 minus 3k. And solving for this, I'll move the 3k over. I'm going to subtract the 9 on the other side. We get k is equal to 3 as well. So this would be an algebraic way of finding k. Now, finding k is just the first step, because when we find k, that tells us it's going to be term number 4. And this question said, find the term containing x to the 9 in the expansion. So term 4 will be 9, choose 4. Our first term was 3x squared, 9 minus 4. And our second term was negative 2 over x to the 4. Do each of these separately.
Why is it 4?
Because on our formula, it's term k plus 1. And if we found k was equal to 3, then it will be term 4. Oh, yes, but here, yes, sorry, this should all be, thank you. Yeah, that's a mistake there. This will be 3, this will be 3, and this will be 3. Yes. But it will be term 4, because k is always 1 less than the term number. So now we go to our calculator and we go 9, choose 3, and that's 84. So again, figure out each of these things separately. 3 to the power of 6 is 729. X to the 12. Negative 2 to the power of 3 is going to be negative 8 over x to the 3. Now, when we multiply all of our coefficients together, and this is why we do them all separately, so we make sure that we can keep our negatives. This isn't subtracting. This is going to be 84 times 729 times a negative 8. We get negative 489, 888. And we have x to the 12 on the top, x to the 3 on the bottom. That'll leave us with x to the 9. So we do get some large ones, large numbers, when we simplify this. So these ones where you have to find k first, these are the most difficult questions. And if we could make it more difficult, we just have to add some terminology that you might forget. So here's example 5. Find the constant term in the expansion of 5x cubed minus 2 over x to the power of 12. I believe you learned this first in grade 9. What does constant term mean? It's a term with no variables. It's just a number. Okay? Now, finding the constant term means if there's no variables, it's like having an x to the 0. Because x to the 0 is 1, and then you would just have a number. So in the expansion, if we take out our formula and we put in everything we know, we don't know k. So I want you to look at it for about a minute and see if you can do the trial and error and see if you can plug in some values of k, find one that doesn't work, and then try to find the one that works. You want all your x's to cancel out to get an x to the 0. So you need the same number of x's on the top here as you will get on the bottom over there. And the best way is to try find one that doesn't work and then adapt from there. So Erwin, tell me a k value that doesn't work. K equals 4. So if we start with k equals 4, 12 minus 4 is 8. Can you see that that would give you x to the 24 here on top? And you would have x to the 4 on the bottom. If that's simplified, you'd be left with an x to the 20. We want all the x's to cancel out. So what does that tell us? Should we make k bigger or smaller if we want more to cancel out? Some say bigger, some say smaller. Bigger? So tell me a k value bigger than 4 that still doesn't work. K equals 8. So now if I try 8, okay, 12 minus 8 would be 4. That will give me x to the 12 up top and give me x to the 8 on the bottom. Subtracting and simplifying, that would leave me with x to the 4. We're getting closer, right? We're getting closer to them all canceling out. And after doing this a couple times, which one works? K equals 9 is the one that works. Because if I went to k equals 9, that would give me x to the 9 on the bottom, and 12 minus 9 is 3x cubed to the 3 is x to the 9. They'd all cancel out, and you'd get your constant term. So now that we know k is 9, we can find out it's going to be term 10. 12 choose 9, 5x cubed to the 12 minus 9, and negative 2 over x to the 9. Again, we go to our calculator. Solve each of these things separately. So 12 choose 9 is 220. 5 to the power 3 is 125. X cubed to the power 3 is x to the 9. Negative 2 to the power of 9 is negative 512. And if we multiply all those numbers in front together, we get 12,800,000. And our x's all cancel out, so we found the constant term. So questions from your homework that deal with finding a specific term is question number 9.